Good afternoon, everyone, and welcome to today's webinar. Today, we're going to be discussing building code basics for historic Main Street. This webinar is going to be broken up into two parts, so you're getting part one today, and then tomorrow afternoon at 1 o'clock again, you're going to see part two. With us today, we have two great presenters from Schooley Caldwell. Before we get started with introductions, I just wanted to go over a couple quick things for everyone. First of all, if you are looking for AIA credits for this session, you need to attend today and tomorrow. In a little bit, I'll be putting in a sign up sheet in the chat. So just click that link, make sure you enter your information so we get you recorded for both days so we can get your credits transferred to you. We will be taking questions at the end of today's webinar. But if you have questions during the webinar, please type them in and we will get those answered once the formal presentation ends. And finally, if you have any issues today, Zoom's being weird, just close it down, click the link that was sent to you, and sign back in. That way, that usually solves the problems that you're having. So with us today, we have two presenters, as I mentioned, from Schooley Caldwell. First with us today, we have Melinda Shaw, and Melinda is an architect and COO of Schooley Caldwell, and she's been working for over 20 years with historic buildings for public and private clients. And also with us today, we have Amanda Fuson, and she is an architectural designer and has been a Schooley Caldwell since 2015. Thank you both for doing this webinar today. Without further ado, I'll turn things over to you to get started. Thanks.
Thanks, Evan. We're happy to be doing this again. We actually originally put this together for the conference this fall, and it's back by popular demand. Who knew that many people were interested in the building code? This really is designed to be building code basics. If you are a licensed architect that do this all the time, you'll probably find this a little simple. That said, if you are someone that just bought a historic building and going, now what do I do with it? This is just right presentation for you. So that said, it is still an AI accredited presentation, so you can get your health, safety, welfare credits. Um, so a little bit about it. We are going to be talking about the history of the building code, how we got to where we are, some reasons why the building code exists as it does, and how you go about applying the building code to your historic Main Street building. So a few learning objectives because we're required to list them for the AIA. And then the fun thing, why do we actually have a building code other than it seemed like a good idea? So way back in 1755 BC, back in Babylonian times, there's a Hammurabi's Code. And you may have heard this before because there are all sorts of things codified in it. This is one of the earliest examples of any kind of building code we've seen. Obviously, a long time ago. This one, as an architect, I'm glad it is evolved because pretty much anything the architect or contractor did that went wrong, the architect or contractor was put to death. Thankfully, things have changed and evolved over the years, but this really is the first example of trying to hold buildings to a certain standard. So not having walls that fall over, just really making sure that buildings were safe for people to occupy. And it wasn't until about nearly 3,000 years later, after many disasters and other things, they really started looking more seriously at how and why our buildings are being built. So there's a Great London Fire of 1666. In that fire, in 4 days, 85% of the city of London was completely destroyed. So 13,000 houses, 87 parish churches, St. Paul's Cathedral, and most of the city's buildings. That is a lot that was destroyed in only 4 days. As a result of that, they actually did pass the Rebuilding London Act that same year, and they started requiring houses to have some fire resistance. They started widening roads because everything had been leveled, so that was easy time to do it. You were no longer allowed to build out over the roads, so that helped fight the fires. They also started looking at other things about what materials things could be built out of. Houses started to have to be built out of brick and stone, which you'll find as we get into this, that started being a precedent for other things. So over the years, we really have noticed a trend where the building code is reactionary. These are some early codes in the US. The earliest one in the US really being Boston outlawing chimneys made with wood and thatch, or chimneys made out of wood and a thatch roof covering. If you looked at any kind of fires recently, and they've been in the news a lot, it's like that seems like a no-brainer. Why would you build a chimney out of wood? But it was allowed prior to that. Um, and gradually, every time there was a great fire, you would see not long later, they would start coming out with more and more guidelines. All through the 17 and 1800s, there was a series of fires that would level large parts of the cities. And not long after, you'd start sometimes in that city, sometimes in another one, you would see building codes start to get tougher, whether it's introducing what buildings could be made out of, how far apart they had to be, roofing materials, a variety of things. Eventually, the first code was published around 1900, and gradually adapting that into the world's first model building code around 1915. So it took a while. And it wasn't really into the 1970s that it started calling for one more consistent code throughout the US. Every jurisdiction up until that point would have its own building code, which makes life really interesting, trying to go back and figure out what code applies to what building. So fortunately, starting in the 1970s, we did still start to see a more consistent code. Eventually, we got to the code we have today, which even then it is updated every 3 or 4 years, and every state and jurisdiction can still slightly change it, but it is all based on one main building code. So, but again, building codes are reactionary. And they also set the minimum requirements to protect public's health, safety, and welfare. So building codes aren't there to prevent fires. They aren't there to hold contractors to a higher standard. They really are setting the minimum requirements. So you're always allowed to go above and beyond what is required. So one of the other big fires that really kind of sparked the interest in improving our building codes is the Triangle Shirtwaist Factory. And if you ever start studying the series of tragedies and things that led to our building code, this is a big one that comes up. This is one even I remember in architecture school. So this building was built in 1901 in New York City. It's about 10 floors, and it had two regular stairs plus one fire escape, which was allowed per code. It was fine. The challenge is when a fire broke out on the ninth or on the eighth floor, the ladders from the fire department could only extend up to the seventh floor. That's important. You'll see that later. Even codes today, there are different requirements that start being implemented once a building hits a certain height, and it's for exactly the reasons that happened in this building. A lot of the victims of this fire were killed either from smoke inhalation or for trying to jump because they were so desperate because the stairwells had been locked. The stairwells were locked, the fire escape failed, the elevator failed. So sadly, it caused the death of 146 garment workers. Truly a large tragedy. It led to legislation that really improved both building standards and factory standards, resulted in 38 new laws regulating labor and other things in New York City. So it was a big change. It also helped push sprinkler systems, fire alarms, and other things. Now, the crazy thing that a lot of people don't realize is the Triangle Shirtwaist building itself, after the fire killed a lot of people, but this building is actually still standing and it is still in use today. It did not destroy the building despite all the loss of life. And we'll see that happen a few times. We're going to have a strange interest following these disasters. So you'll see us pull up a couple different disasters throughout this presentation. It's interesting to see what causes the building code that we have today. So looking at what the building code is, a lot of times people assume the building code is one big thick book. There is one big thick book, but that is not all it is. So right now here in Ohio, we have the Ohio Building Code 2024, which is based on the International Building Code. Um, it is always a few years behind the International Building Code because, as I mentioned, each state can make a few alterations to it. So it takes them a while to go through, see what the IACC has updated, and make their changes. So, but really the Ohio Building Code is made up of the one code, but then also a mechanical code, a plumbing code, an electrical code, energy codes, um, all sorts of different codes, plus accessibility standards and other things. Um, so really it's a stack of books. And in addition to those main ones, one thing you'll come across a lot in historic buildings is the Ohio Existing Building Code, which is an entirely, in theory, separate code that can be applied to existing buildings since they were built to different standards. Um, and an Ohio residential code that is more designed for 1, 2, and 3 family residential houses, which is a separate standalone code. Now, in addition to all those books, there's also a lot of reference standards that all apply to the building code and make it is what it is. Um, Now, you don't need to go out and purchase every single one of these to understand the building code, but there are a few key ones that are important to understand that you see pop up a lot. One is the American Institute of Steel, if you're doing a steel building. ANSI standards come up a lot, the American National Standards Institute, including with accessibility things. ASHRAE comes into play when you're doing anything mechanical related. Um, all sorts of things, ASTM standards, and UL is another big one. UL is the underwriters laboratory, the people that fire test and safety test a whole lot of things. So, but all these other standards also play into the building code that we have. And depending on what part of it you're looking at, you may need to go pull a different book. So from that, where do we get started? Because it is a lot of information. I don't recommend getting started by just pulling the building code off the shelf or finding it online and starting to read it cover to cover. That is a quick way to take a nap. So if we have, this is our little example building. You'll see it throughout the presentation today and tomorrow. We have called it 101 Main Street in Somewhere, Ohio. It's kind of your typical Main Street building that you'd see downtown all throughout Ohio, where you might have retail on the first floor and residential or offices on the upper floors. So if we have this building, next thing is where do we start? So really you start by having to gather a lot of information. Before you even crack open the code, you need to know how big your building is. That includes how tall it is, how many floors it is, and how many square feet per floor the building is, because it probably varies per floor. Then you need to know what is it made out of. Most typical buildings like this in Ohio are made of brick. Is all of it made of brick? What are the walls made out of? What is the floor made out of? The roof structure, because sometimes it varies from building to building. Then also, what use is it right now? What use was it originally, if you know that? And what is the planned use for that building all throughout the building? As you'll see, that really comes into play with how the building code applies to your building. And the last thing is context and site. How far is this building away from other buildings? And zoning restrictions. So on top of all these other building codes, there are zoning restrictions depending on where you are. You might have to go through a historic commission meeting. You might have different zoning restrictions and parking requirements, all sorts of things. So make sure you understand your local zoning. So with that, we get into construction types.
So beginning with construction types, we're essentially talking about what is a building made out of and what are the code implications that has. Construction types are categorized by materials based on their resistance to fire and structural applications. So the idea is that construction type gives us some indication of the time available for evacuation, for firefighting, and emergency response in a building under fire conditions. So in new construction, an architect might assign a construction type based on a host of reasons or conditions. In adaptive reuse, though, our construction type is an existing condition that we need to identify in order to understand how to design and implement new elements into the building. So actually, if you can go back one, Melinda, looking at this diagram, there are 5 distinct construction types, which range from type 1 being the most resistant to type 5 with the lowest fire resistance. And these are categorized based on material, like I mentioned. And what this means is that buildings of fire protected steel or concrete, as seen in type 1 and 2, provide more fire resistance than, say, wood construction. And subsequently are allowed greater height and area. And this can be great because with more fire resistance comes increased occupancy, but with that also comes added cost. So in new construction, your selected construction type will inform how high and how large you can build. Therefore, at the beginning of a project, it's important to assign what type you have so that you can then follow that throughout the code and how you design the rest of your building. So as a quick overview, looking at this, type 1 is non-combustible fire resistive construction. It is typically constructed of steel and concrete, making it the most resistant to fire. And these are typically reinforced concrete structures with either concrete encasement or spray applied fireproofing. They're typically your high-rise or multi-story buildings in urban settings, or parking garages, where in addition to the non-combustible structure, all other building materials are also non-combustible. And these buildings make sense. They have the highest level of safety. And since the structure is able to withstand fire for 2 to 4 hours, they have unlimited height and area restrictions. But they are also the most expensive to construct, which makes it less likely to use in other situations like single family residential or smaller buildings where cost is a concern. Type 2 is non-combustible construction. These are typically steel or concrete, but all other interior building materials are also comprised of non-combustible materials. It's very similar to type 1, the difference being that it does not have that additional level of fire resistive coating or fireproofing applied to the structure, which makes it a little less fire resistant. And these are typically your big box stores, your malls, schools, and these buildings are able to withstand fire up to 1 hour, but depending on the use classification, they will have a limited height and area restriction. But it kind of makes sense that if you were building a school or a big box store, chances are you only want to build 1 to 2 stories anyway. So this selection would be more appropriate than, say, type 1. Because limited height really isn't a concern for you, and it's more expensive to build type 1. Type 3 is also known as ordinary construction, and this is a hybrid of combustible, non-combustible. So the exterior envelope is masonry, so brick, concrete block, or other non-combustible material, but the interior structure, the roof, and partitions are all wood framed. And this is called ordinary construction because this was really typical in industrialized cities in the turn of the 20th century. And you see these all over historic uptown. So these are your main street buildings, and very similar to our case study that we're looking at. Type 3 buildings have a 1 to 2 hour exterior wall rating and may have a 0 to 1 hour interior wall rating, depending on a few other factors, which we'll get into later. Type 4 is heavy timber construction, and these are typically constructed of heavy timber columns, beams, or glulam beams. And these are typically your old barns or warehouses, or in the left photo, our office right behind me. And these buildings actually perform well against fire because the material takes longer to burn, and you can actually visualize the impact of the fire on members, such as charring, as opposed to steel. It may be more expensive than other types of wood frame construction, which we'll get into, but it has much more fire protection. And then type 5, lastly, this is combustible construction, and it is constructed of any allowable material, including wood, which leaves it very little fire resistance. And these are your single family residential homes, restaurants, small office buildings. It can be metal framed as well, but it's typically wood. And type 5A would require 1 hour of protection at the exterior walls, but type 5B has no rating whatsoever. And as such, it has a lot of limitations in regards to height. It can only be built 40 to 70 feet above grade, but it's less costly. And you would look at this if you were building a single family home or a smaller structure because it's more cost efficient. Okay, so as mentioned earlier, construction types are categorized based on material, and that materiality will dictate the rating of building elements. And when we say rating, we're talking about how long that structure has for evacuation and emergency response under fire conditions. So in this table on the right, you'll see that depending on the construction type, as they're listed in those headers at the top, your bearing walls, your non-bearing walls, your roof structure will be required to have a certain rating, meaning that that building element can withstand fire for X number of hours, which you see listed in the table. And each construction type is also broken out into groups, which you see A and B. And that's really just A has an additional hour of protection for even further fire resistance. Next slide. So the required rating of the different construction types is also correlated to how tall you can construct your building. And it's pretty common sense. If you want to construct your building taller and larger, it needs to have greater fire resistance. And whether or not you're building a sprinkler will have even further impact on how tall you're allowed to build. So, for example, as seen in the highlighted columns, type 1A, which is the example here, must be constructed of a 3-hour structural frame, meaning it's the most fire resistant, and as such, it has unlimited building height, which you see on the right. That UL just means unlimited, since it's that protected. And again, these would be your urban high-rise buildings, so that makes sense. On the other hand, type 5 buildings, again, these are your smaller wood construction. They require no structural rating, and they have a very limited height of 40 to 50 feet, which you see in this example of a commercial occupancy. But it makes sense for that building, for a building that is constructed to withstand fire longer, would have those unlimited heights and areas, whereas there are many more limitations placed on less safe construction types. And the goal of assigning these types is to kind of mitigate that risk that comes with fire based on the material to ensure safe evacuation for all, as that's always our number one goal. Okay, so assigning construction types for new buildings makes sense, but what do we do when we come across an existing building with existing conditions? In adaptive reuse, the construction type is an existing condition that you need to identify in order to design new elements into the building. So whether it's a renovation, an addition, an extension, you need to identify what the existing shell really is. And you kind of have to work backwards and understand, what is my building made of? So for this case study, our building at 101 Main Street, Somewhere, Ohio, let's say it is a typical ordinary construction. So it's masonry exterior walls, it has wood framed floors, maybe the interior has wood partitions as well. So if you go to the next slide, based on those structural components and what is going on in the interior, we are able to identify that this is type 3B construction. And looking at the table, we can see that type of construction, the walls are 2-hour rated, but the interior partitions aren't required to be rated at all, unless required by the occupancy, which we're going to get into next. So use types. Use types, this is a classification of the building's use, and it's an essential component of the building code. It helps us determine how people move through a space, how they occupy a space, and how they'll evacuate a space. And subsequently, we'll have um, safety measures associated with those uses. So while in a new building, we would identify the occupancy of a building first and assign a construction type, maybe in conjunction with that, based on what makes sense. In adaptive reuse projects, it's often the opposite. So we're faced with an existing condition, an existing building, and it is what it is. And it's our job to determine what occupancy makes the most sense based on the owner's program and kind of look at what makes the most sense for that building's reuse that is in compliance with code. So a client may come to us and define the need for a building, and we'll try to incorporate that, but the existing conditions will really determine where we go from there. So how do use groups work as it relates to the code? And it's actually separated, the code actually separates them into groups called occupancies, which you can see here. And each occupancy has very specific requirements related to what we've talked about before, area, height, and egress. And it's the job of the architect to determine what occupancy of a building should it be classified as. So the established occupancy groups you can see here, starting with assembly. So this is where larger groups of people are gathered together. So let's say we were designing a theater for a client. This is how that would be categorized. Business, these are your typical office buildings. Educational, these are a space with classes up to 12th grade. And you can see the others. We have factory, institutional, mercantile, which is a type of retail space, residential, which is the code breaks down even further, but that's kind of an overview, and storage. And we want to determine what occupancy group that the use of the building or parts of the building most closely resembles. And in conjunction with the existing floor area, we can determine the number of occupants allowed within that space that we can design for that space. But all of this construction type, occupancy, they're all necessary for determining egress, height, and area. Okay, so the use of a building code, the use group in a building code has many implications, including how tall a building can be constructed. We saw that in construction types, but it also applies here, and they work in conjunction with one another. They also have implications on the number of exits required in relation to area and use, distance to those exits, and whether or not sprinklers are required. And once you've identified the construction type and occupancy, you can start to identify what those implications are. So for our case study here, we've identified it as 3B construction. So that's your ordinary masonry building, wood framed interior, with say mercantile on the ground floor, business on the upper floors. That's pretty typical in your Main Street buildings. So the allowable height here would be 55 to 75 feet, and you can see that highlighted in the table on the right. So we have our occupancy classification, and where that meets with the type is where our height limitations will fall. So no 4-story rooftop additions happening on this building. So essentially the code is balancing fire resistance of the construction, so of the material, with the way people will be using the building, and whether or not there are additional safety measures like sprinklers in determining these things. So another impact that occupancy has on code is whether or not a building is required to be sprinklered. And we've kind of gone over this up to this point, that if you do have sprinklers, regardless, it adds that extra level of fire protection that then you have less restrictions in how tall and how big you can build your building. But when are they actually required? So more or less, oftentimes they are, but depending on the conditions of, so assembly always required. Business, it depends. So all buildings with an occupant load of a certain amount, or 55 if the building is 55 feet above grade. And you can see these other examples. It's related to the number of occupants in the building, or if it's above 12,000 square feet is where a lot of these other uses fall. So when we say occupant load, we're talking about the number of people that the space is designed for. And when we say egress, we're talking about how they're going to safely evacuate the building. And for adaptive reuse projects, our construction type, as we've mentioned, is existing, and in conjunction with occupancy will determine the egress requirements by code. So when we say occupant load, how do we determine that without getting too far into the weeds? The code determines an amount of square footage that each occupant needs depending on the use type. So you can see highlighted here on the right, if we have a building that has a mercantile use, so a retail use, it's allocating 60 square feet per person in that condition, versus business, also highlighted, it's allocating 100 square feet per person. So you can kind of quickly do the math. For instance, if we had a 3,000 square foot office floor and we have 100 square feet per person, you can determine, 30 occupants per floor. It's kind of that simple type of math, but it gives us an idea of how many people we're designing a building for. So once we've determined the occupancy load per floor, we can determine the number of exits required. And 49 is a really big number in the code. It's that point at which you are pushed over the threshold of needing more than one exit. So for occupancy types, mercantile and business, an occupant load that exceeds 49 people will require 2 exits. And we'll dig into how we calculate that tomorrow with our case study. But the big takeaway here is that the use of the building and the number of occupants will impact the required number of exits. And it also determines how far those exits can be. And you can see that all highlighted in the table. So for business, exits can only be a certain distance away at any given time. And with the sprinkler system, keep coming back to that, it adds that extra layer of safety, which then decreases those limitations.
So frequently we get people that'll come to us and it's like, okay, I got this building, I need to get it up to code. And that's always kind of a vague statement. People intending to do the right thing for their building. But the important thing to understand with buildings being up to code or meeting code is that if there have been no changes in use or major upgrades or changes to the building, a building is up to code as long as it is compliant to the code it was originally built to. So if you have a school that was built in 1920 and it has continued to be used as a school, you have made no major changes to it, it is technically still up to code. Now, that said, there are accessibility standards and other things, other laws that it may be not compliant with, but it is compliant with the building code. So that falls into, I'm going to include a few sections here from the building code in case you ever need to go back and reference them. You do not need to memorize these. But section 102.7 existing structures says the occupancy of any structure currently existing on the date of adoption of this code shall be permitted to continue without change, provided there are no orders of the building official pending, no evidence of fraud, or no serious safety or sanitation hazard. Basically meaning if you've kept your building in good condition, you haven't changed how you're using it, you haven't made it less safe, you can continue using it as long as you want. Now, that's not necessarily always practical. We often try to improve on things from what they are, but that is the basics of what it's allowed. Now, that said, if you have allowed this structure or a previous owner has allowed the structure to fall into unsafe conditions, it has become a hazard, it's has been vacant, then you need to start bringing the building up to code. So anytime the building department has decided it is inadequate because to meet egress, or that the light and ventilation, or that it's a fire hazard because it has not been maintained, you will need to bring it up to the current codes to make it safe. So, and again, if you start restoring the building, you start making serious upgrades to the building, at that time you also need to look at bringing it up to what the current code is. Now, the extent that you need to bring it up to the most current code will vary depending on exactly how much you're doing. And this does still say you can either bring it up to the current code or chapter 34. That has actually changed. It is not chapter 34 anymore in Ohio. That used to be the existing building chapter. Now we have an entirely new building code, all for existing buildings. So, but that is for a future webinar and not tomorrow, because that's 2 to 3 hours all on its own. So the other big thing that will trigger making code updates to a building is changing its occupancy. As in this picture, it's an old fire station. It was originally a fire station. It then became a retail shop of sorts. And it is now in the process of becoming home to the Columbus Historical Society. So it went from an institutional use to a mercantile use. And now museums are, depending on their type, either a business occupancy or an assembly occupancy. And sometimes that varies within one building. But because it's gone through all those changes, we need to pull a building permit, make updates, and they will not issue a certificate of occupancy until it has been brought up to current code requirements. So, but at the same point, if you have a space within a building that, even if you're making other changes to the space, if to the building, if you have a big space like this courtroom where you are not changing the occupancy of that particular space, that space could remain in use as it was originally intended within certain guidelines. So there are limited updates that might be required in a historic courtroom like this, even if we're making a lot of updates elsewhere in the building. So that said, again, there are accessibility requirements. Accessibility requirements can be triggered both by the building code, the amount of money being spent in a building, and just the part of what covers accessibility is actually a federal law separate from the building code. So accessibility is ruled by a lot of different things. So when in doubt, make your buildings as accessible as possible. So looking back at our case study, if your existing building has a restaurant on the ground floor, has 2 floors of offices, and you want to change it so it's restaurant on the first floor, but hey, apartments have become really trendy downtown, and I want to make updates to that, because there is a change in use, you're going to need to look at making changes and updates to that building, not necessarily just to the 2 apartment floors, but how those apartment floors relate to the restaurant, because it's not just about the individual use, but about the relationship between uses. Part of the reason that exists, or good case study as to what happens when you ignore these, because these requirements have been around for a while, and this tragedy was less than 10 years ago. There was a large fire out in California, the Ghost Ship Warehouse fire. It was a former warehouse, and without pulling any permits or asking any permission, someone turned it into an artist collective with living spaces and a concert venue. So you have 2 uses, one that has a high number of people in it, and another one that has people sleeping in it, which both have very stringent requirements, moved into a space that was originally just for housing stuff and not people. And it never went through any kind of plan review. And previously it was specifically restricted where residential and entertainment uses were prohibited. They ignored all that. Most of the electrical system, as it turns out, they had made the alterations using extension cords, which not a good thing. It had no fire alarms and no sprinklers. Um, Unfortunately, there had been a number of reports made to the building department. They had tried to start investigations and deal with it, but before they could get access to the building, there was an electrical fire. At least they believe it was started by an electrical fire. There was so much fire and smoke that spread throughout this building because it was all wood construction, no regulations, no separations, no egress signs, no emergency lighting. People couldn't find the exits, and 36 people died. It resulted in a lot of criminal and civil lawsuits that I have feeling still aren't completely resolved. So, very tragic condition, but a good example of just how important it is really to make sure if we're going through a change in use to really look at what is happening with that building and making sure that existing building can handle that new use.
Okay, so some resources to help understanding code implications of an existing building, just as quick references. UpCodes, this is a really great resource. It's an online code compliance platform that has all current and past Ohio building codes. And as a quick reference with all the sections that we discussed today. Accessibility requirements UpCodes also has the latest ADA standards. Again, these are the federal standards that set minimum requirements to make a building accessible, as well as ANSI 117, which provides the technical guidelines on how to make those elements accessible. And then one of the National Park Service briefs actually covers preservation as it pertains to building code, and it provides guidance on how to meet the goals of building codes while also preserving character. So looking at if you're going to have sprinkler heads, if you're going to have just other penetrations or modern systems within a building, how can you hide those or design in such a way that they are less noticeable, have less visual impact on the overall feel of the space? And then rated assemblies. When we talked about ratings of a building, we accomplished this by using tested assemblies. So these are assemblies that have already been tested for to see how those structural or assemblies perform under fire conditions. And then also there is a way to dig into like what is the fire rating of an existing building. This is an existing condition. It obviously doesn't have any UL assembly since it was constructed or it has a structure that no longer is done today. So we can look at archaic materials and assemblies provided by HUD, and that helps us to break down, okay, I have a clay tile structure or other structures that you just don't see as much today, and can assign a rating to them.
Yeah.
Is there anything else you want to add to this, Melinda?
I think those are the main lists. And then just so you know what's coming tomorrow before we get into questions and answers. Tomorrow we will talk more about common issues we often see relating to code in buildings. What happens when you want to add sprinklers, or why should you add sprinklers to a building and how they work. The egress components of the building. So how are people getting out of your building? Because ultimately building codes are not meant to necessarily save a building. They are meant to get people out so buildings don't kill people. And then accessibility standards, which is always a big part of working on old buildings, starting to look at energy efficiency, and then some more case studies and resources. So with that, Devin, it's time to answer questions.
Thank you, Melinda and Amanda. As mentioned, please type your questions into the chat box now, and we'll get those answered in order as we receive them. I'm going to put back in the chat box as well the link in case you signed in a little bit afterwards. If you're looking to get AIA credit for this session, you need to attend today and tomorrow and just complete the sign up sheet for today, and there's the link for that right now in the chat. Let me see. Let me open up our questions here. First question here, Melinda. When you were mentioning at the beginning of the webinar, you had said that things can still vary slightly state to state. What are some examples of like Ohio versus Indiana or Michigan or anyone else?
So Ohio does still have a few things that vary. One of the ones is in residential, so we don't deal with it as much, but I have been following it, is looking at starting to require sprinklers in residential. That impacts more the residential code. Another big one that has starting to impact the commercial code in Ohio is requiring storm shelters in school buildings. That was added into the international code a while ago. Then our legislature took it out for Ohio for a while because the sheer cost and difficulty of doing it, and it is now back in with the current one. If you get the Ohio code, it actually does do a fairly good job underlying what is different between the Ohio code and the model international code. So there's just some little quirks over the years. Sometimes it's things that may be good to adopt, but for one reason or another, Ohio isn't quite ready to adopt as well. So it changes with every version of the code. So it's always a fun year or so of learning the new building code when it changes.
Thanks. Can you go back to the resources slide? Somebody was trying to write down
Sure.
the web address for the archaic buildings.
Yeah, I love that book. So anyone that names a book that fire ratings for archaic materials, and that one is particularly useful if you work on old buildings that have clay tile structures, either walls or floors, cast iron, plaster, because those are not assemblies that are typically used or fire rated anymore. But we have found that jurisdictions, because that is a government publication, accept that the ratings that are listed in that book as good as a UL rating. So.
Thanks. Next question here. I believe you answered this later after they answered or asked the question, but we'll just ask it again. Can a building have more than one occupancy use? Like a museum might be institutional and assembly.
Man, did you want to answer?
Sure. Yeah. Building can definitely have more than one use. It's pretty common. What you get into there is that depending on the use, certain uses will be required to have a rated separation between them. So assembly uses are always separated. From other uses, depending on, in terms of a historic building, if it is an assembly use in an existing building, you're renovating this building, it's had no change in use, and you have an assembly space with offices, that may be considered by the building department to be acceptable, and you might not need to provide an additional rating between those uses because the use has not changed. The safety factor will not have changed from before the renovation to after the renovation. So, yes, you can have multiple uses within a building.
I would say, if anything, I would say the majority of the buildings, at least that we work on, have more than one use. Now, how
Yes.
much? Yeah, it's pretty unusual for a building to only have one use.
Next question here, kind of the one after it, kind of a related. So this is going back to the, I believe, the ghost ship fire. What measures do you think would have been implemented had the building department successfully evaluated the warehouse before the fire?
I would say they probably would have been kicked out at the end. I mean, especially just even by zoning, none of the uses that were they had moved into that building would have been allowed. So, um, you know, and if they were taking a warehouse and starting from scratch saying, hey, we're going to take this warehouse, we're going to do it properly, go through the building department, draw up these plans, it would have had, if it was multiple floors, it would have had egress stairs that were enclosed. It would have had rated corridors. The structure may have been required to have a rating. It certainly would have had exit signs. It would have had a legal electrical system that wasn't just based on it running extension cords. It would have had fire alarms. It would have had more exits. There's a whole lot of things. There's really nothing about that building that was code compliant at the time the fire occurred, which is really the tragic thing that They couldn't stop it before it happened.
And kind of relating to that, and in recent California fires as well, how does the building code address toxic materials for things like smoke hazards and asbestos use and things like that?
Yeah, and that's the interesting thing. So asbestos, is a big toxic material, don't want to use it anymore. The good thing is when it comes to fires, asbestos is actually a really great at preventing or the spread of fires. It's kind of ironic. There's a reason asbestos was incorporated into so many different things. Um, so it's not necessarily toxic, but there are when we talked at the beginning about all those different reference standards in commercial buildings, there are a lot of regulations over what can be in the building, how different materials are treated, um, and and that's partly because of the depending on what a material is treated with, how flammable, like a wall covering or something is, will impact what kind of smoke it produces, which can impact getting people egressing safely and firefighters being able to fight the fire. Tomorrow we'll actually look at another case study example of another building that survived the fire, spoiler alert, but it's because of all the materials that were on the wall that wouldn't fit modern codes, that it was a problem. So,
Thanks. Next question here is how do you deal with gas fumes from fireplaces and kitchens? And I guess this could apply for both commercial and residential.
so you definitely have to follow the current mechanical code. There are, and it's changed with this last round. Just, things have to be exhausted. Fireplaces have certain requirements based on what type of fireplace it is. The more multifamily you get, the more stringent those requirements are. Especially kitchens have to have hoods, usually not recirculating hoods. They usually have to be direct vented outside. But then it's a matter of, if it's multiple stories, if you're making a shaft, shafts going through multiple floors, multiple apartments is protecting them. So it is something you have to think very deliberately about. There's a reason if you look at new multifamily projects, they are directly venting out at every unit and not just taking things up to the roof because it is a lot of work.
And another question here is radon a problem for reuse projects?
So I would definitely say it can be based on where you are. Radon being an issue, it is an environmental site specific issue. So if you are worried about it, have your site tested. Um, the one challenging thing, testing it early before you start construction. If you have a building that is not sealed up very tightly because it has been abandoned for a while, it may pass the radon test just because it is being well ventilated. By the time you fix it and seal it up so it meets energy code, it could be a problem. Um, so it really is best to have a radon professional test it and come in and look at it. So
Thanks, Belinda. Next question, our always perennial question when it comes to historic buildings. Do I and when I need an elevator?
and we will get into that more tomorrow with accessibility. So to
Now
come
you have to
back.
come back
So
for tomorrow for your answer.
exactly. So it very much depends on your use. How many, what is your use? Who is the building open to? How tall your building is. So we'll get into that tomorrow.
Thanks, Belinda. I
Yep.
do not see any more questions. So if you have any pressing questions and you don't want to wait till tomorrow, type them in now so we get them answered. I just want to thank Belinda and Amanda again for doing this webinar. We'll be with them tomorrow again at 1 o'clock tomorrow. If you haven't received the sign up, it's on our website, heritageohio.org. You can sign up there. It's also on Facebook, LinkedIn, a couple other spots too. So no more questions. So thanks again to everyone for attending today. If you need the sign up sheet, it's in the chat right now for the AIA credits. Recording of this webinar will be sent out to you later tomorrow. I might wait actually just until tomorrow's webinar is over and I can bundle them together to keep the emails down to you. But thanks again to everyone. Thanks to Melinda and Amanda, and we'll see you tomorrow. Thank you.
Thanks, Devin.
Thank you.